Hi everyone, this is the most important lesson in integral, and I would like to do it step by step and show you everything, so you see everything here. So look at this. If I have integral of this one, okay, which on the radical I don't have x, and on the radical I have another function. So it is like f of g, and it is like composite function, okay? So instead of x on the radical, you have 2x plus 4. So in this case, I really don't know what to do, because if it was integral radical x dx, it will be integral x power this dx, which is x power this divided by this plus c, which is x power 3 over 2 divided by 3 over 2 plus c, which is 2 over 3 root 3, root x cube, okay, plus c. So if I have x, just x, I can answer. If I have integral x power n dx, I can answer. This is x power n plus 1 divided by n plus 1 plus c. I can do that. But how about sorry about that. How about if it's not x, it's not x power n, it's not radical x. Instead of x, I have something else. I have another function. For example, instead of ln x, I have ln something else. Instead of e power x, I have e power something else, which is another function. What should I do? So I want to remind you, if you remember, I want to remind you u that we had, and I talked about u prime and those things. So here also I can do it with u. Okay, so you have to take something which is bothering you, okay, and if you didn't have it, you didn't have any problem, and you would well be to do it as u. Sorry about that. So see, if I have just radical x, integral radical x here, I can do it. I can do it. I did it. I did it here. Okay? So this is the answer. But I don't have x on the radical. I have something else. So that something else is bothering me. So I have to take as this as u. Okay? So I would say u is 2x plus 4. From now, I want you to listen this part carefully and try to do many questions, because it helps you to learn integral, and if you learn it, it's very easy. You can do any question. So u is that, okay? But I have dx there. I don't have du. And if I take this as u, okay, I can say it is integral radical u dx. Then you tell me, if it is radical u du, I can answer exactly the same as first line here, okay? Because it's radical x dx, so I can answer. But here is radical u dx. What should I do? U and dx. I don't know what to do. So I tell you, do derivative of both sides. Du. So du is, derivative of u is 2 dx, because derivative of 2x is 2, so 2 dx. Then find dx. Solve for dx. Dx is du divided by 2. Then substitute this there. Okay, so I have this star equal, so integral u, integral radical u du divided by 2. Then I tell you, for 1 over 2, is it bothering you? You say no, because I can bring it out. That's a number. When you have a number, no problem, bring it out. Okay, so 1 over 2 radical u, integral radical u du. Perfect. Now I can answer, because it's u and du. It's based on u. So it doesn't matter. It's like x dx. It's like z dz. I can answer. So this is 1 over 2 integral u power that, which is 1 over 2 u 1 over 2 plus 1 divided by 1 over 2 plus 1 plus c, which is 1 over 2 u power 3 over 2 divided by 3 over 2 plus c, which is 2 over 2 times 3 u this plus c. I can cancel 2 and 2, and the answer is this guy. Okay? Can I say I'm done? You tell me, but in the question I see x, here I see u. What do you mean? So I say, okay, go back and substitute. Substitute u. What was u? 2x plus 4. So it is radical 2x plus 4 power 3 divided by this plus c. Okay? So you look at your integral and see your integral has radical, and you say, if I have radical x dx, I can answer. If I have radical u du, I can answer. If I have radical z dz, I can answer. But here I don't have. I have something else under radical. So I take that as u, I find du, so I substitute, then I see I have u and dx. So I find du, I find dx, I substitute, and then I see my integral is based on u and du. Remember, u should be something which you can find its derivative easily. Derivative of u is 2, easy. So I don't take radical as u, because then the derivative is hard. Okay? And I don't need. So you have to take u something when you do the derivative. It's easy. Also, when you do derivative, when you substitute, when you do all of them, you have to reach to something that you are able to do it. See, you are reaching to this that you know how to do. You know how to do this integral. Okay? Usually, you have to take u something which is bothering you. For example, under radical, in the bracket. Okay? In the bracket, but without power. You don't need. Okay, you don't need the power, because then it will be hard to find the derivative, to find du. Okay, and then substitute, find the answer, again go back, substitute u, what was u, and then you are done. Okay, see here it's talking about all the process which I did here. Okay, so all of these, so which I just showed you in the question, it's talking about those. Okay, so here you can read those steps. Okay, you can read those steps. It says define a variable as a part, so you have to define u here, u as something. Okay, and then you find du, and then you solve for dx, find du, and then solve for dx, and then substitute. Okay, and then integral will be just based on u. You can find the answer, and then again you go back and substitute. Okay, so this is all I did in the question. Let's do here. What did I say? I said in the bracket on the radical, that should be u. Okay, so I think, and it's not end of the word, I can change my u, because maybe students, they say, okay, I do u equal to x, and then what is du? 2dx, and then what is dx? Du divided by 2, but it doesn't solve your problem. You have on the radical is bothering you, so this is not the thing. But it's not end of the word, change it, so you don't have too many things, so you have several, so you can change it. Okay, then when you learn, you don't make mistake. Okay, so I say u must be x squared plus 3. I said don't take the whole radical, because then it is hard to find du. Okay, I do u this. What is du? Du is 2x dx. What is dx? dx is du divided by 2x. Now I substitute. Okay, so integral 2x radical x squared plus 3 dx is 2x radical u du divided by 2x. Oh, I can cancel this and this. Okay, so now I can find the answer, right? That's good. So now I have integral u power this du, which is u power 1 over 2 plus 1 divided by 1 over 2 plus 1 plus c, which is 2 over 3 u power 3 over 2 plus c, which is 2 over 3, what is u? X squared plus 3 this plus c. Okay, so again I don't take u equal radical. I don't do that. Okay, I don't need to do u as that. I just have to take under the radical. Okay, so I do under the radical as u, and then du is the derivative. Okay, I find dx, I substitute, then I see, oh, perfect, 2x and 2x cancel. This is very good. When you continue and do many practice, when you look at here, you see, okay, if this is u, then du is this and this. And then you say, oh, perfect, this is good. Okay, and then from here I can just from here everything is based on u, and I can find the answer, but I have to go back and substitute because I asked you what was egg, what is u, I don't know what is u. Okay, so this is the thing here. So how about this one here? Okay, this one here. Okay, what do you notice when you look at this? You notice this. What is that? This is derivative of ln x. Oh, perfect. So what happens if I do u equal ln x? If u equal ln x, du is dx divided by x. What is dx? dx is x du. Okay, so your integral is ln x dx over x, which is u x du divided by x. Can I cancel x and x? Perfect. Remember, if you are left all with u and you can find the integral easily, you didn't make any mistake. But if I see x is still there and I cannot cancel, I made a mistake. Okay, so it is u du. Oh, perfect. I know. It is u power 2 divided by 2 plus c. Don't forget c. Now what is u? Oh, u is ln x. Okay, so ln x squared over 2 plus c. Remember, this guy is 2 ln x, okay? But not this one. Because sometimes I see a student when they do this, they write 2 ln x. No. Wrong. Correct. Here you have ln x squared, not ln of x squared. Everything is squared, okay? So these are not the same. These two are not the same. They are different. Okay? That's good. So how about this? How about this one? Okay, so I look at here and I see, oh, I have something power 6. If I take everything as u, this is hard to find the derivative because I have to do 6 bracket power 5, then u prime. So I don't do that. See, if I do u equal x cubed plus 3 power 6, then what is du? du is 6x cubed plus 3 power 5, and then derivative of inside. Oh my goodness, this is hard. Okay, so I don't do this. How about if I just do u inside the radical? Sorry, inside the bracket, or just under the radical. Okay, that's perfect. Okay, so I do u as x cubed plus 3. What is du? 3x squared plus, no, 3x squared dx. Okay, what is dx? Dx is du divided by 3x squared. Oh, perfect. So I can do this. Integral x cubed plus 3 power 6, 3x squared dx, which is u power 6, 3x squared dx, du divided by 3x squared. I can cancel this, and then the answer is u power 7 divided by 7 plus c. What was that? So this is x cubed plus 3 power 7 divided by 7 plus c. Done. Okay, so I stop here and I continue after. Let me see if how many examples. So okay, we reached to practice. Okay, good. So I continue after this. Okay.